Problem diagnosis is the first step toward competent brake system service. You must determine what problems are in the system and decide what repairs must be made to remedy these problems. To diagnose a brake system, first use symptoms, noises, smells, abnormal brake pedal or steering wheel movement, improper braking action, to analyze problems. Listen to the customer's or service writer's description of the problems. If not unsafe to drive, road test the vehicle to verify the trouble. Then, inspect the brake system to pinpoint the exact sources of problems. You will then be prepared to decide what must be done. For example, brake pedal shimmy is a very common problem. The brake pedal actually vibrates up and down during normal braking. The most common cause for this is rotor runout on the front of the vehicle. Excess heat can cause the rotor to warp or develop heat checks or hardened areas. This runout will transfer motion back into the brake system and to the brake pedal. The brake pedal will only vibrate when braking. Sometimes you can also feel severe runout and vibration in the steering wheel. This is usually due to runout in the front discs of the car. Drum brakes can also develop runout, which can cause vibration. Since drum brakes are on the rear of the vehicle, runout is not as detectable in the steering, but can be felt slightly in the whole body of the car. Squeaks when braking may be caused by a wear indicator rubbing on a rotor, by glazed lining, foreign material embedded in the linings, or a shoe loose in its caliper. If linings are completely worn down to the metal, a loud grinding noise will be produced when braking. The metal part of a pad or shoe will grind against the metal part of the drum or disc. Severe rotor or drum damage can result if the driver continues to drive the car with this metal-on-metal contact. Here's an example of how a driver abused his brake system. The metal part of the pad rubbed against the metal part of the rotor with catastrophic damage. The customer had to purchase new rotors and drums, a very costly mistake. Squeaks and rattling can also result if wear makes a brake pad loose in its caliper. The pad can also make squeaking noises where it contacts the caliper piston. Another problem is brake pedal drop. When at a stoplight, the brake pedal slowly moves toward the floor. Pumping the pedal can momentarily restore the pedal to its normal height. When this happens, it indicates a bad master cylinder. The master cylinder is usually leaking internally and must be replaced or rebuilt. Fluid level in the master cylinder reservoir may not drop because fluid is leaking internally. If the brake warning light is on, it also indicates a leak in the system or a low fluid level. The brake pressure switch might have turned on the light, warning of unequal pressure in the system, normally due to a system leak somewhere. First, make sure that the master cylinder is full and air has not entered the system because of a low fluid level. Normally, the fluid level should be about 1/16 of an inch down in the reservoir of the master cylinder. Add fluid if needed. If the reservoir is empty, you've probably pumped air into the system. Then, inspect around major components for signs of leakage. Look for wetness or dark brake fluid areas around the caliper pistons. Check around brake hoses and lines which can deteriorate and leak after prolonged use. Wiggle hoses and check them right next to crimp fittings. Any sign of darkness or wetness indicates leakage. Look for leaks behind and underneath the master cylinder. Fluid can leak out of the back of the master cylinder and down the booster or firewall. Rubbing your finger under the bottom rear of the master cylinder will often find a leak. To diagnose computer-controlled anti-lock brake systems, you must use a scanner or dedicated tester like this one. It plugs into battery power and into the computer system diagnostic connector. When powered up, this vehicle-specific tester will show the system troubles quickly and efficiently. When using tester instructions, you can troubleshoot wheel speed sensor circuits, solenoids, servo motors, and other electronic components in the ABS system. Danger: some anti-lock brake systems operate on over 2,500 psi. Bleed this super high pressure by pumping the brake pedal several times with the engine off. Then it should be safe to work without injury. To inspect drum brakes, remove the drum. If rusted to its flange, rap the drum with a hammer to free it. You may also have to break off locking clips from the lug studs. This will expose the drum brake components for inspection. The brake shoe linings must not be worn thinner than approximately 1/16 of an inch. The shoes should not be glazed or coated with brake fluid, grease, or differential fluid. Also check the return springs and other parts for signs of overheating damage, often caused by someone leaving the emergency brake on while driving. Check at the wheel cylinder boots for leakage. If the boot is full of fluid, the wheel cylinder should be replaced. Do not use compressed air to blow brake dust off of wheel brake assemblies. Many brake linings are made of asbestos, a known cancer-causing substance. Use a special brake vacuum machine to remove the dust. It will surround the brake assembly and keep any contaminants from entering the surrounding area in your shop. Remember, breathing asbestos dust may not seem to hurt you right away. However, it can cause deadly lung cancer after exposure. Various vacuum systems are manufactured. Follow the instructions provided with the specific piece of equipment. Generally, to use a brake vacuum system, mount it over the brake assembly. A large rubber diaphragm fits around the backing plate. Insert your hands through the enclosed rubber gloves, then use the air nozzle to blow dust off of the assembly. The vacuum system will then pull the dangerous asbestos dust down into a storage container. Inject air into all rivet holes, onto the backing plate, wheel cylinder, and other areas holding this harmful dust. Taking the time to use a vacuum machine is a very wise investment of time. The vacuum system will keep cancer-causing asbestos dust out of the shop area. To continue disassembly, use a brake spring tool to remove the upper shoe return springs. Fit the tool over the anchor pin and turn. This will force the upper end of the spring off of the pin. Wear eye protection in case the spring flies into your face. Organize the springs so that they can be installed in the same locations. The primary and secondary springs are usually a different color and tension. Use a hold-down spring tool to remove the hold-down springs. Push in and turn to free the spring cup from its pin. This will allow the spring and cup to pop off of the shoe. Repeat this on the other hold-down spring. Lift the adjuster rod or cable off of the backing plate and shoes. Since drum brake designs vary, you will have to modify repair procedures slightly depending on the type of brake assembly. A lever type adjuster and a rod type adjuster require slightly different service methods. However, if you keep your parts organized on your cart or bench, repairs are fairly similar. If you are concerned about proper reassembly, simply rebuild one side at a time. Then you can look at the brakes on the other side of the car as reference for installing all parts correctly. Lift off any other brake components like this strut. It is important to note the exact orientation of parts, like this lower spring. If installed backwards, it will keep the star wheel and automatic adjuster from working properly. Often, with the shoes off of the backing plate, you can remove the lower spring easily by simply swinging inward on the top of the shoes. This will free the star wheel and spring. To remove the emergency brake lever, you must pry off a C-clip like this one. If you find fluid leakage after pulling back one of the boots, replace the wheel cylinders. To remove a wheel cylinder for replacement, unscrew its brake line and the fasteners securing it to the backing plate. Wipe a small dab of white grease onto the pads of the backing plate. This will prevent the shoes from squeaking when rubbing against the backing plate. Don't use too much grease, or it could get onto the brake shoe linings and ruin them. Fit the emergency brake lever pin through the shoe and install its C-clip. Place a small amount of grease on the star wheel and screw it together. The star wheel threads must not be rusted or dirty. The wheel must turn freely so that the brakes will adjust automatically. Install the star wheel and lower spring onto the bottom of the shoes, making sure the spring is positioned correctly. Place the shoes on the backing plate and install the hold-down springs. Guide the hold-down pins through the holes provided in the shoes. Use your fingers to push on and guide the pins through the shoes, springs, and cups. The emergency brake actuator or cable guide often fits under one of the hold-down springs. Use your hold-down spring tool to compress the spring and fit the pin through the outer cup. Turn it about a half a turn to lock it in place. If used, slide the strut down into place between the tops of the shoes. Make sure the forks on the ends of the strut slide over the shoes completely. Next, fit the automatic adjuster return spring into place. Force it into position between the lever and the shoes. Make sure the spring fits over the dimple on the shoes so that it won't fly off. Check that the star wheel teeth are touching the adjusting lever. Next, properly position and install the shoe retracting springs. Pry the end of the spring over the anchor pin. Repeat this on the other retracting spring. Wiggle the shoes sideways to center them on the backing plate. To service a brake drum, locate and record the drum's discard specification. Determine the drum diameter and set the drum micrometer to indicate this reading. Place the micrometer inside the drum. Read the number indicated by the pointer. Mark the location of your reading, then check the drum at several different locations. Different readings indicate an out-of-round condition. The highest number that you read must be compared to your discard specification. If this number is greater than the discard specification, stop. Inform the customer that the drum has served its purpose and must now be replaced. Micrometer readings less than the throwaway specification need to be subtracted to determine the amount of material left in the drum. Record this amount. If full of brake fluid, clean the drum thoroughly before mounting it on a brake lathe. Install the correct adapter on the lathe. Install the centering spring and select a cone of the correct size to fit the center hole of the drum. Place the cone and then the drum on the shaft. Place another floating drum adapter on the outside of the drum. Add spacers to fill the shaft and screw the left-hand threaded arbor nut onto the end of the shaft until snug. Here is a special drum mounting adapter for a foreign car. The drum bolts to this adapter. If the drum has internal bearing races, you must use small cone-type adapters like these. Remember that the drum silencer band must be used before machining begins. Loosen the set screws and slide the cutting tool until the cutter tip is all the way to the rear of the drum face. Tighten the set screws while slightly rocking the cutter tool front to rear until the cutter tool is tight. Move the cutter tool away from the face of the drum by turning the cross slide crank. Turn the carriage hand wheel until the cutter is positioned roughly 1 inch from the edge of the drum face. This should be the same position that you measured or marked during the drum measurements. Turn on the lathe. Carefully turn the cross slide crank until the cutter tip slightly touches the drum face. Hold the cross slide crank with one hand and turn the micrometer dial with the other hand. Set the dial to reflect the same reading that you obtained with the drum micrometer. Rotate the cross-slide crank so the cutter tip is moved away from the face of the drum. Move the carriage traverse crank so the cutter tip is over the deepest groove in the drum. Crank the cross-slide wheel until the cutter tip begins to cut the drum face, and continue cutting into the drum face until a light cut line is visible around the entire diameter of the drum face. Read the cross-slide micrometer. Compare this second number to your discard specification. If the deepest groove exceeds your discard specification, you can tell your customer that the drum is bad before you cut the drum beyond discard. You've given every consideration to the condition and size of the drum. Rotate the cross-slide crank back to the original drum micrometer reading that you took with a cross-slide micrometer. Turn the carriage hand wheel so that the cutter tip rests on the outside edge of the drum face, and remove the rust ring by turning the carriage hand wheel. Move the cutter tip with the carriage hand wheel until the cutter tip is all the way to the back of the drum, and again remove the rust ring. Turn the cross-slide hand wheel until the micrometer indicates that you are taking half of the cut required to take out the deepest groove. Engage the automatic feed, and the lathe will make your first rough cut. Feed the cutter in again to the depth needed to completely remove the deepest groove in the drum, and again engage the automatic feed for your final cut. Remove the drum without touching the machined surface. To pre-adjust the brakes, fit a gauge into the drum and lock it down. Then, fit the gauge over the shoes. Turn the star wheel until the gauge just touches the brake linings. This will position the new shoes close to the drum and pre-adjust them. Sometimes a hole is provided in the drum or backing plate for shoe adjustment. Use a brake spoon to turn the star wheel until the shoes rub lightly on the drum. If serviced, you must bleed air from the wheel cylinders. Have someone push lightly on the brake pedal while you open the bleeder screw, or use a power bleeder like this one. When inspecting disc brakes, first check the condition of the rotors. They should not be badly scored, or they would require replacement. Also inspect the caliper for signs of trouble. If the brake pads or other parts need service, begin disassembly by forcing the caliper pistons back into their bores. Use a large C-clamp or even a screwdriver. Next, unscrew and remove the special bolts that hold the calipers onto their knuckles. Normally, 2 bolts hold each caliper. If rusted, use emery cloth to polish these special bolts. If the calipers are not going to be replaced or rebuilt, use heavy wire to hang the calipers up and out of the way. This will prevent damage to the brake hoses. Lift off and mount the caliper on these hooks if needed. Remove the old pads and further inspect the pistons for signs of leakage. Push on the boot to check for signs of weepage of fluid. If caliper service is required, unbolt the brake hoses from the rear of the caliper. A banjo fitting usually holds the brake line on the caliper. Don't lose any special brass sealing washer that fits between the hose fitting and the caliper. This washer must be reused to prevent leakage. To service the brake rotor, first measure its thickness using a special brake disc micrometer with pointed anvils. Try to measure the deepest groove in the rotor. Compare your measurements to specifications. Minimum rotor thickness is normally cast or stamped somewhere on the rotor. If worn more than specifications, stop and inform the customer of the thin condition of the rotor and that it is not machinable. If your reading shows you have enough thickness left, you are ready to machine the rotor. Inspect the rotor for loose, cracked, scored, or chipped races. clean out the hub so that you can mount the rotor on the brake lathe. Select a collet that fits into and contacts the inner race properly. Select a collet for the front race. Add enough spacers to fill the shaft. Then screw on the left-hand threaded arbor nut. Use the spanner wrench provided with the lathe to tighten the arbor nut. Just snug down the nut, don't over-tighten it. Place a silencer band of the appropriate size on the rotor, or use the clip-on silencer if you're working on a solid rotor. Before mounting the hubless rotor, ensure that the entire rotor has been properly cleaned and is free of dust and road grime on the inside surfaces. Locate and mount a hubless rotor adapter. Mount the centering spring and a cone that fits the center hole of the disc. Mount the other hubless rotor adapter to the outside of the disc. Fill the shaft with spacers as required and place the arbor nut on the end of the shaft. Position the disc cutters on the lathe so that they can reach the inner edge of the rotor face. Tighten the pivot post nut with a rotor tool in this position. Turn the cross-slide wheel until the cutter tips are in the same general location where you took your micrometer readings. Turn the lathe on. Locate the right depth wheel until the cutter tip on the right side just scratches the surface of the rotor. Set the micrometer dial to 1/2 of your initial micrometer reading. Repeat this procedure on the left side as well. Retract the bits from the rotor and turn the cross-slide wheel until the bits are over the deepest groove in the rotor. Turn the depth of cut dial until the bit cuts a continuous groove in the rotor. Read the micrometer dial and compare this reading with discard specification. The combined or total readings on both sides of the rotor will tell you if the rotor can be cut to the deepest groove and still be within discard specification. Retract the bits from the rotor surface and move them to the inside of the rotor with a cross-slide hand wheel. Return the bits to the last reading that you had on the deepest groove. Lock the cutter tips and place the select knob in the correct position. Then engage the automatic feed. Make sure, however, that you are not removing too much material at one time. Refer to the lathe instructions for details. Generally, most lathes will cut about 40 thousandths of an inch during each cut. If you must remove more material, make 2 cuts. Rotor and lathe damage can result if you try to machine off too much metal at once. After cutting the rotor, remove it from the lathe and clean the bearing races. You want to ensure that there are no steel chips in this area. Reassemble the disc brake in the opposite order of disassembly. After installing the disc, fit the new pads into the caliper. Make sure all anti-rattle clips are installed correctly. If the clips are badly rusted or weakened, use new ones. Keep oil and grease off the pad lining material or the new pads can become glazed and squeal. Fit the caliper over the rotor and install the special bolts. Push them through their bushings and wiggle the caliper until you can start the threads. Torque the caliper bolts to specification. Master cylinder service normally involves replacing the old unit. Remove the brake lines from the side of the master cylinder and pull them out of the way. Then, remove the 2 bolts that secure the master cylinder to the brake booster or to the firewall. Using a long extension and swivel socket will often simplify this task. Fill the new or rebuilt master cylinder with brake fluid so you can bench bleed it. Install fittings into the cylinder outlets and route the hoses back into the reservoir. This will simplify bench bleeding. Use a Phillips screwdriver to pump in and out on the master cylinder piston. This will force fluid into the cylinder and remove air. Then you can mount the unit on the car. Tighten the mounting nuts properly to secure the master cylinder in place. Then hand start the brake lines to prevent cross-threading. It is very easy to damage fittings and master cylinder threads, requiring time-consuming thread repairs or part replacement. Use a tubing wrench to bleed each brake line. Have someone operate the brake pedal while you crack each fitting. Then refill the master cylinder. A final question you must ask yourself: is the car safe? Test drive the car to verify your repairs before releasing it to the customer.